Today we are going to talk about these theorems over here on the left, but one thing I need you to keep in mind is that these theorems work only when we have sets of parallel lines. So we can see right here and here we've got a couple of parallel lines. We know that because of this marking right here, that those two arrows in the middle of the line show that they are parallel to each other. And we have this line that crosses both of them. It is what is called a transversal. So a transversal is simply a line that crosses through two other lines. And in this case, when it crosses through those two parallel lines, we get two sets of angles. And all of these theorems refer to those sets of angles right there. We're going to start with the consecutive interior angles theorem. This one is also known as the parallel postulate. The parallel postulate states that if we have two parallel lines, then those parallel lines have interior angles that should add up to 180 degrees when we add them together. That would be true for angles 4 and 6. That would also be true for angles 3 and 5. Now, we call this the consecutive interior angles theorem because if we go along this transversal and we take a look at these angles that are all right in a row from each other, created by that, then 4 and 6 kind of line up in order along those. So we call those consecutive angles because they're in order. All right, so the consecutive interior angles theorem says that these two angles should add up to 180 degrees if they are working with parallel lines. All right, the next thing we're going to talk about is the corresponding angles theorem. Now, corresponding angles, if we take a look at these two sets of angles, corresponding angles are ones that are in the same position. So 1 and 5 would be corresponding angles to each other. 2 and 6 would be corresponding to each other. 3 and 7 and 4 and 8 are corresponding angles. So we have 4 pairs of corresponding angles. Corresponding angles are congruent to each other. So angles 1 and 5 are congruent, and so forth with all of those pairs of angles. Next, we've got our alternate interior angles theorem. So these 4 angles right here are called interior angles because they are in between those two parallel lines. Alternate interior angles are on opposite sides of the transversal. So 5 and 4 would be alternate interior angles. 3 and 6 would also be alternate interior angles. And the alternate interior angles says that these two alternate interior angles are congruent to each other. Next, we're going to do the alternate exterior angles theorem, and that's just this set of angles right here because exterior refers to the fact that they are outside of those two parallel lines. Alternate are on opposite sides, so 7 and 2 would be alternate exterior angles, and the theorem states that those are congruent to each other. 8 and 1 would also be congruent to each other. So those are our 4 theorems that give us a lot of information about these angles. Sometimes you'll see a diagram that shows it like this, where 8 and 5 are congruent to each other, and 4 and 1 are congruent to those two. 7 and 6 are congruent to each other, and 3 and 2 are also congruent to those 4. We could also bring in vertical angles, because you can see vertical angles right there with 7 and 6, and the other pairs as well are congruent to each other. And so there's a lot of different ways of showing congruences with this situation, with parallel lines. So we are going to use those to solve some questions. So we want to find the value of x. All right, we're going to do this in 2 parts. Now we know angle 1 and 136 degrees right here are supplementary angles because they make a straight line. So 136 plus the measure of angle 1 should equal 180 degrees. And if we subtract that 136 from the 180 degrees, 136, then we get our measure of angle 1. So measure of angle 1 should equal 44 degrees. So we'll put that over here in this corner. Angle 1 and this angle over here are alternate exterior angles. So by the alternate exterior angles theorem, 44 and 7x plus 9 have to be the same measure because they are congruent to each other. If we solve this equation, then we can figure out our value for x. So we'll subtract 9 from both sides. That gets us 7x left on the right-hand side, because 9 minus 9 is 0. 44 minus 9 is 35. We'll divide by 7, and we end up with x equals 5. So that is our solution to that question right there. Now this situation, we're supposed to find the values of x and y, and we can see that we've got two parallel lines up here and up here. Now if we kind of picture these two as transversals, then that shows us that we've got some consecutive interior angles there and some consecutive interior angles right there. So using the consecutive interior angles theorem, or parallel postulate, that shows us that these two angles, here and here, should add up to 180 degrees. So we get 2y plus 2x plus 12, add those things together, and we get 180 degrees. Now I wouldn't be able to solve this for x or y by itself. We have two variables, so we need a second equation right there. And that's where this comes in. We get 4x plus y plus 6. Those are also consecutive interior angles. They should also add up to 180 degrees. Now we can use the method of our choice. This is now a system of equations to solve for one of our variables. I'm going to use substitution. We'll solve for this y right here. So I'll subtract 6 right here. Subtract 6. We end up with 4x plus y equals 174. Subtract the 4x, subtract the 4x on this side. We end up with y equals 174 minus 4x. We can now substitute that right there. So we're going to plug that into our other equation right here. That'll give us 2 times 174 minus 4x plus 2x plus 12 equals 180. All right, we're going to solve this one for x. First step is to do the distributive property. So we end up with 348 minus 8x plus the 2x plus 12 equals 180. We're going to combine some like terms, which are our x's here, and then the numbers right there. So 348 and 12 make for 360, minus 8x and the 2x together make negative 6x, and we get 180 on the other side. All right, we're going to subtract the 360 from both sides. We end up with negative 6x equals negative 180. All right, now we divide by negative 6, divide this by negative 6. We end up with x equals 30. Okay, we're going to take that value now. We're going to plug it back in up here. And if I do that, I should be able to figure out my value for y. So that gives us y equals 174 minus 4 times 30. Negative 4 times 30 is negative 120. So we end up with y equals 174 minus 120. And that will give us a value of 54 when we're done. So we've got our y value, we have our x value, and we are done. Thank you very much for watching.